All right, well, welcome in everybody. Thank you for joining us today for our intro to baseball analytics in R. We are very happy to have Jim Albert, Distinguished Emeritus Professor from Bowling Green, to join us. He's going to be walking us through a markdown file. We only have a 45-minute session here built in. And if you ever worked with any kind of statistical programming or any programming in general, 45 minutes is a blitz. So, this is really meant to give you a dip your toe in the water, kind of see some of the possibilities and see what you can do with some of the sports data. One of the real benefits of a lot of this statistical computing in sports is there's a lot of data available online, a lot of data that we can grab and use and just start to answer questions. So I'm going to go and turn it over to Jim. He's going to first walk us through how to get a document downloaded, the document that he's going to be running through today. He'll talk through it a bit, but you'll have the entire document that you can kind of look through and refer to as we move along, so you don't have to get worried about getting lost in a lot of typing. So Jim, I'll pass it off to you.
Okay, great. Well, thanks for the opportunity to talk about baseball and R, which I've been doing for a while. And okay, so as you've seen, this is this website. This is the link for the website that gives you into my repository. And then you'll see a Columbus 2021, you'll see a file, a markdown file. A simple way of getting that on your computer is to open up a new R markdown file. And then what I would do is just go open, and then I would just basically paste in what you get from the web. Just put in exactly the same material here, and then you'll get exactly what I have here. So that's a simple way of getting that material on your desktop.
And Jim, I'm going to go ahead real quick just to make sure. I'm going to share my screen.
Okay, sure.
Everybody has this down. So go to our browser. bit.ly/rbaseball.
Yes, correct? Right. And you click on that's the one.
Here, Columbus, November 2021.
And there is the file.
We'll click here. If you click this little button right here, it'll copy the entirety of this to your clipboard. So then when I open up RStudio, which was mentioned that we need to have that downloaded. If you don't have that downloaded, I would just recommend kind of watching through this link. I'm assuming will persist. Was that correct? That they can download they can download the document afterwards?
Yes.
Okay. So come in here to File, New File, R Markdown, just as Jim showed us. It might ask me because I haven't downloaded all the updates on this computer. It might go through that. You can go through those processes as he showed you, and then just paste all of the stuff that you just copied. It's going to ask me to install. We don't need to watch all this, but it's going to paste all the stuff that he just copied, paste it right into that R Markdown over top of what the default is there, and we're good to go. So I'm going to stop my share and pass it off. I just want to make sure that we're getting everybody in the right frame of mind to make sure that we have the data set ready to go, and we don't lose anyone at the very beginning.
Okay, great. Okay, so
you should be able to share again.
Okay. So what I want to do, I plan just to walk through this document then, and so I have a little introduction. I'm sorry, wrong one. There's my file. Okay, so my plan is to illustrate using several packages in the Tidyverse suite, which is called dplyr and gplot2. And so, okay, there's the link. Okay, so getting started, I'm going to load in 4 packages. And when you have a markdown document, you can have these little code chunks, and I'm going to execute the code chunk by just hitting this little arrow on the right, and that'll read in those 4 packages. So here's my story. It's about home run hitting in baseball. And StatCast is our current type of data that we get. And the first season of StatCast, there were a total of 4,909 home runs hit. And remarkably, 4 years later, there were 6,776 home runs, which is a 38% increase. So suddenly, there are a lot of home runs. Now, but what's interesting is that 2 years later, we have actually got a downturn, only 59.44 home runs. So it's dropped by 12%. So we want to get some understanding about what's going on in baseball. Why is there such a big rate increase and then now a decrease in the home runs hit? Okay, so we're going to discover two things. One is we're going to discover that actually batters are hitting the ball harder in this season compared to 2019. Now, if I just told you that, that would make you think that you have more home runs hit in the current season. But what's interesting is that the characteristics of these baseballs in these two seasons are not the same. It appears that the 2021 balls are deader. They don't carry as well as the 2019 ball. And that has led to the decrease in home run hitting. So we're going to discover that by exploring some data. So anyway, the data is a subset of some StatCast data. So what I did is I collected data for 2 seasons, last 2 full seasons in baseball, and there are over 246,000 rows in this data set. And so I'm going to read this directly from my GitHub site by using the read$CSV file. So that's the function, and I'm going to read in all this data. Shouldn't take very long, and it's read in. Now, let me show you that the data set is stored in a data frame called SC. And I'm going to show you the first few rows. So here's the data, what the data looks like. We have a season indicator. We have a name of a player. These are all balls that are put in play. So there are 2 main measurements off the bat. One is the launch angle, which is the angle that the ball hits off of the bat. And the launch speed, that's the launch angles in degrees. And the launch speed is the speed of the ball as it leaves the bat. And that's in miles per hour. And then it will record if the ball hit was a home run or not. So a home run will be a 1, and home run HR0 will be a no home run. And so it's a pretty small data set. We only have 5 variables, but it's interesting. It's rich enough that we can ask some interesting questions about home run hitting. The first thing we want to do is we want to connect the values of the launch variables with home runs. Okay, so what angles and what launch speed do we need to hit a home run? And so what I'll do is I'll construct a scatter plot. So what I'm doing here is I'm using a package called ggplot, and I'm going to only look at data for the 2019 season, and I'm only going to look at the home runs that are hit. So I'm using the filter function to extract the rows of my data frame, which correspond to 1 season and only home runs. And I'm going to do a scatter plot of launch angle and launch speed. And now it turns out if you plot this, there's some discreteness in the data, so to make the data less overlapping, the points less overlapping, I'm going to use a jitter geometric object. When I do that, I get this scatter plot. So I get a big mass of points, and this gives me an idea of what values of launch angle and launch speed result in home runs. And so now there's some unusual outliers here. For example, it appears there was a home run hit in 2019 where the launch speed was under 80 miles per hour, which is a little surprising. I'm assuming that was a inside the park home run, but we could check that. But anyway, so what we see by looking at this graph is that all the home runs happen to hit, or generally happen when the launch speed is between 15 and 45 degrees, and the launch speed is between 90 and 120. It's a pretty large, big range of launch angle and launch speed. So one natural question to ask is, okay, if you hit a ball, say at about 100 miles per hour, what is the most desirable launch angle for hitting a home run? In other words, what launch angle would maximize the chance of hitting a home run, assuming you hit a ball about 100 miles per hour. And we're going to discover this by doing some data operations. What we're going to do first is we're going to consider only balls around 100 miles per hour. So we'll look at all balls that were hit between 95 and 105 miles per hour. And for each launch angle, we're going to, now it turns out that the launch angle in this database is recorded the nearest whole number. So we can look at every possible launch angle. We're going to compute the count, how many batted balls there were, and what fraction were home runs. And we're going to plot the fraction against the launch angle, and we'll discover, what is the optimal angle for maximizing the chance of a home run. So that's my 3 steps. And here's the operations. First thing I do is I'm going to only look at balls that are hit between 95 and 105. So I'm using a filter function to do that. And I'll put the new, so I'm taking a subset of rows of my data frame, and I'm storing it in a new data frame called SC100. And I'll do that. And then I'm going to group these batted balls by launch angle. Okay, so I'm creating little subgroups. And for each subgroup, I'm going to find out the number of batted balls, and I'll compute the rate of home runs, which is the, remember, HR is 1 if it's a home run or 0 if not. So I'm going to take the sum of home runs and divide it by the number of batted balls. And that will be the home run rate. And I'll store this. So I'll do this. I did that already. And I'll store this into a data frame called S. Let me show you what that S looks like. So S, basically, for every single launch angle, it's going to give you the number of batted balls and rate of home runs. Now, not surprisingly, there was a ball that was hit. That must have been a ground ball where the launch angle was -82. Not surprisingly, that one batted ball was not a home run. Okay. So what I'm going to do now is I'm going to graph. I'm going to look at only, all I care about, you don't hit a home run unless the launch angle is positive. So I'm only going to look at is the rows of this data frame where the launch angle is positive. And I'm going to do a scatter plot of the launch angle and the home run rate. And there's my picture. Okay, well, we're getting a pretty good idea now. It looks like the rate of a home run looks like it's around highest around 30 degrees. So 30 degrees appears to maximize the chance of a home run. Okay, that's sort of an optimal launch angle. Okay, now, so that's interesting. Now we want to compare the 2 seasons. And so one question is, are players hitting the ball harder in the 2021 than they did in 2019? So we want to look at the fraction of hard hit balls. Now, I think there's an official definition of hard hit ball, but we're going to say that a ball is hard hit if the launch speed exceeds or is at least as large as 100 miles per hour. So I'm going to compute the fraction of hard hit balls for each season. So what I do is I basically do a similar operation as before. I take, by the way, this little symbol here is called like a piping operation. Basically, it's a way of passing a data frame to do an operation. So I'm starting off with the whole data set. I'm going to group the data frame by season. And for each, so there are 2 seasons. And for each season, I'm going to compute the percentage of batted balls where the launch speed is greater or equal to 100. By the way, sometimes there's some missing data. sometimes they don't record the launch speed correctly and there's a missing value. And so I want to take away, by going this NA.rm equals true, I want to remove those missing values before I compute the mean. Now, this will give us a percentage of batted balls, at least 100 for each season. When I do that, I find out that in 2019, percentage of hard hit balls was 21.6. This season, it was 23.2. Well, it's gone up, right? So clearly, it looks like our batters are hitting the ball harder in 2021. But here I'm considering all batted balls. But in terms of home runs, I'm really most interested in the batted balls where the launch angle is around 30. So we'll say between 25 and 35 degrees. So I want to do the same thing, but all I want to do is look at the hard hit balls, which are in 100 miles per hour or more, where the launch angle is between 25 and 35 degrees. So basically what I do here is I group the data by seasons, and again I look at I want this to be the mean. I want to look for launch angles at least 100, and launch speed is at least 100, and launch angle is at least as large as 25, and launch speed is less than or equal to 35. And I find that in 2019, the percentage of batted balls of this type was 3.39. This season was 3.66. So again, not only are batters hitting the ball harder, they're hitting harder at the right launch angles. Okay. So therefore, based on what I've done, you would think there would be more home runs hit in 2021 because the players are definitely hitting the ball harder. So let's go look further. We're going to look at these hard hit balls, the ones where, again, 100 miles per hour and launch angle between 20 and 40 degrees. And for each of those, for those hard hit balls, we're going to look at the fraction of home runs. Okay. So what I do here is let me walk through this code. I start off with our main data frame of all the data balls. I want to only look at the rows where launch speed is at least 100, and the launch angle is at least as large as 20, and the launch angle is less than or equal to 40. So I'm only looking at those rows. These are the hard hit balls with good launch angles. And then I want to group this data by season. And again, I'll look at the number of balls of this type. HR is the count of home runs, and HR rate will be the home run rate, and it's a percentage. Okay, well, look what happened. Now, here's interesting. In 2021, there were more batted balls of this type. There were 8,038 in 2019. There are 8,402 in 2021. But here's the count of home runs. Look at the count of home runs went down. So even though there are more hard hit balls of this type, the fraction of them that are home runs has dropped, and dropped really in a significant way. It's dropped from like 64% to 56%. Okay. And that's very interesting. So something is going on with the baseball that is causing this drop in home run rate. Okay. Now here I looked at all the balls that were hit at least 100 miles per hour. And maybe I can change that to 110. 110 that's a pretty hard hit ball. I mean, when you hit 100 miles. So basically you think then, at this hardness, you expect the ball to be a home run. So again, I do the same operation, but now I'm looking at all the balls where the launch speed is at least as large as 110. Again, the launch angles between 20 and 40. I group the data by the rows by season, And for each season, I find the home run rate. Okay, now both rates are in the 90s, which you expect because it's pretty likely to be a home run. But in 2019, 95.3% of these balls were home runs. But in 2021, it dropped to 94.6. So again, there's a drop in the home run rate of these balls that were hit well. Now I want to look at this a little more carefully because this is an interesting finding, right? That the home run rates are dropping. So what I want to do here is I'm going to look at, before I was looking at home runs that were hit at least a certain speed, I want to consider different average speeds. So I'm going to look at launch speeds between like a value minus delta, like plus or minus 2, and so I'm going to look at launch speeds between like 100 minus 2 and 100 plus 2. So here is where it's useful to talk about a function. The function is basically a certain type of collection of statements with the input and output, which will make it easy to do this operation for different average speeds. So what I want to do is write a function where I'm going to enter in, the input will be the average speed. And then assuming, again, launch angles between 25 and 35, and it's going to output the percentage of home runs hit. And it's going to do it for each season. So I'm going to call that function home run rates. And it's pretty simple to write a function. You just go, the key command is function. The name of the function is called home run rates. And I have a single input, which is average speed. Now my delta, which is the plus or minus thing, is 2. And I'm going to look at, again, starting off with my main data frame, I'm going to look at all the balls where the launch speed is average speed minus delta and less than or equal to average speed plus delta. And again, look, I want to consider balls where the launch speed is between 25 and 35. And I'm going to group it by season. And for each season, I'm going to find the number of batted balls, the count of home runs, and the percentage of home runs hit. And that's going to produce a data frame. Okay. Actually, with a single row, actually. And also I want to add the input, which is the average frame. I want to add that to the data frame. So in order to read this function into R, nothing's going to happen. It's going to read this function as an object in the R workspace. So to see if this function works, I'm going to, in order to run this function, I'll just go HR rates of 100. So this will find the number of batted balls around 100 miles per hour and launch speed between 25 and 35, and will give me the rate of home runs for each season. So it gives me 2 rows, one for each season. So here's the, again, interesting that there's more, this is 100 miles per hour is relatively high launch speed. And there are more home runs hit close to 100 than in 2021, but the rate of home runs has dropped in 2021. And this indicates I'm using average speed of 100. Now I did this so I can do this for different average speeds. I can put in, like, I want to do the average speed 90, I would go HR rates 90. Let me show you that. HR rates 90. Okay, so this tells you what happens for 90. Here, the rate of a home run is a lot smaller, but still, the important thing is that it's dropped in 2021. Now, I want to do this for a lot of different average speeds. Okay, so what I like to do is to do this for a lot of average speeds and then put all my results together in a single data frame. Well, there's a really nice function in the, it's called a perf package, where it's called map.df. And what that'll do is, here are all my different inputs. It's going to use this function, HR rates, for all of the different average speed between 90 and 115. And it's going to run all those functions for all those values, and it's going to paste it all into a single data frame called results. So if you look at this data, what this data frame looks like, it looks like, I'll basically show you a few rows of this data frame. And there, see what's happening. It starts off with 90 and then gives you the home run rate for each for 90, and then does it for 91, 92, all the way up to 115. So, okay, now I have this. I'm interested in seeing how the home run rate varies between these two seasons for all these different average speeds. So what I'll do is I want to plot the, on the x-axis, I want to plot the average speed against the home run rate. I want to show separate lines for each season. Okay, so I want to show two lines. And this is how I do it in ggplot. Again, the way ggplot works is you start off with the data frame and you want to plot the average speed and home run rate. And I want to use, I'm going to plot the two seasons by using different colors. And I indicate that by, now it turns out that season is really a numeric variable. This will look a little better if it's a character variable. So I'm just going to convert that to a character variable. And my plotting object is a line. Okay, so if I do that, I get this picture. And you get a nice picture. ggplot will automatically give you a nice legend. And what this shows you is for all average speeds between 90 and 115, the chance of a home run is higher in 2019 than 2021. By the way, if I could change this graph, if I wanted to plot points, I'd go Jim point. Oops. I'll give you a different graph. Like this. So I think the line is a little prettier. Or if you want both the points and the line, you do this. Okay, maybe that's a little better. It shows you the actual data that you're plotting. Okay, so clearly this shows you that the baseball in 2021 is deader. It doesn't carry as well as the ball in 2019. That raises the question, what's going to happen in 2022? Well, if we get past the possible strike in baseball, then we'll find out by looking at the data. Okay, here's some interesting things. Let's look at some individual players. We have a variable called player. And if we look at the two seasons, 2019, 2021, who hit the most home runs? And this is easy to address by using these same kind of operations. Here, we're going to group the data by player, which is somebody's name. And for each player, we're going to find out the total number of home runs hit for the two seasons. Now, I want to create a leaderboard where I have like the top home run hitter on the top. So what I want to do is I want to arrange this data frame by home run. I want to go from large to small. So I want to go from in decreasing order. And I'm interested in showing you the top five. And so Pete Alonso of the Mets hit 90 home runs in these two seasons. You might be interested that the MVP of this recent World Series, Solar, is actually number 4 in this list, which is interesting. So, okay. Here's another question: Who hits the highest? What were the 5 hardest hit home runs hit in these two seasons? Here, we want to look at only the rows where you get a home run. We're just looking at those rows, and I want to look at the launch speeds, and I want to arrange them in descending order from hardest hit to softest hit. Okay, so I'm going to arrange it from top to bottom, and I want to show you the player and the corresponding launch speed. I don't care about the other variables in the data frame. I want to show you the top 5. So Manny Machado was the hardest hit ball in these 2 seasons, 119.6. Cordero was second. Not surprising that Stanton was high in this list. Okay. Now we can easily change this code to talk about softest hit home runs. And all I do is, instead of going decreasing launch speed, I just go, I arrange it from softest to largest. And so here, Ben Gamel hit a home run with only a launch speed of 79.1. And actually, I was able to find the YouTube of this softest hit home run. And you'll see that that was a inside the park home run. This is one of those, slightly hit balls in the outfield, and the outfielder makes a dive for it, and he misses it, and it goes past him, and the guy gets the score. So inside park home runs are always exciting in baseball. Okay, well, let me wrap up what I've done. I've been focusing on using a couple of focusing on graphing, but also the dplyr package is really the workhorse in this thing. And these are the verbs I was using. Filter will choose a subset of rows of a data frame. Often we want to summarize a variable from a data frame. A very common thing in doing this is that often you want to group the data into subsets. And for each subset or each subgroup, you want to summarize. And so group by will do the subsetting, and then summarize will do the summarization for each group. Mutate is a verb for defining new variables in your data frame. We just saw an example where you want to sort the data from small to high. That'd be arrange is the verb for that. And then sometimes we want to, now filter, we select rows of the data frame by going, filter selects rows, right? And select will choose columns. So I saw that earlier. And then I read in a data set from my GitHub site. The general syntax is actually, I misspoke here. It's actually underscore is the right thing. Underscore CSV, that's the command from the read R package. If you have a dot there, that's the base R command. But what this does is you have a data set in a comma separated values format, and you're reading that into R and assigning it to the data frame DF. To graph something, we were illustrating using ggplot. And this is basically how you graph. You start off with the data frame, and you want to have a mapping which shows you, basically tells you which variables you want to graph. I was illustrating, when you graph using a scatter plot, you have to indicate what variable is the X variable, what is the Y variable, and those are called aesthetics. Aesthetics are the roles assigned to variables. And so, like, for example, maybe average speed was the X variable, and home run rate would be the Y variable, and those are indicated under AES. And that will set up, so basically the first part of the ggplot function will define the data frame and also define the variables to graph. And then you have to decide what type of object to plot. Is it a line? Is it a point? Is it a box plot or something else? And that's called geometric object, and there are many options here. And the only other thing I illustrated here was when you have a function which will compute something for a single value, and you want to repeat that over many values, then I illustrate using the map df function. Okay. Now, okay, so what I recommend you do is to get acquainted with this, work through my example, see if you can get the right kind of output. And then here are some exercises that you can try using the same data set. So here's a simple question over this 2-year period. Which player had the highest average launch speed on home runs? Which player had the highest launch angle on home runs? Okay. I always think Hank Aaron, one of the great home run hitters, he was really a line drive hitter. So his launch speed, launch angles, they didn't measure those things at that time, but his launch angles were relatively small. Okay, let's see. For each season, find the 5 hitters with the highest average launch speeds. Do you find the same players in each list? Suppose you hit a ball with launch speed between 95 and 100 miles per hour and launch angle between 10 and 20. Those are not optimal launch angles. We saw 30 degrees was pretty good. What's the chance that this type of ball will be a home run? Here's an interesting question. Overall launch speed, launch angle pairs, which is the most common? You know, which value do you see the most among all the home runs hit? And then I gave you a function which gave you the home run rate for an average launch speed. Let's suppose the input is a minimum launch speed. You want to do a similar thing. And then you want to use the mapdf function to basically apply the function in number 5 over many values. Okay. I think it's about 5 minutes till noon. And so this is a good time to entertain any questions that anyone has about this.
Well, thank you, Jim. I'll kind of moderate the questions if they come in, but do appreciate your time. And just as a heads up to everybody, because I'm sure there's going to be some people here that are, brand new, have never used R before, never used, maybe you're a Python person, maybe you've never seen Python or R. And it can be overwhelming when you see all these numbers and the pipe always scares people when they see it the first time. So I think the point here is really to think about the questions that Jim is asking and the questions that he's getting at and how he uses the data to get at those questions. One of the questions that popped in here was from Phil Buck. It wasn't really a question, but it says he was involved with the baseball deconstruction with Meredith Wills. That was a discussion that happened over the past couple of years with the new ball. And I know, Phil, you can either, I guess, if you'd like to speak to it, you can put it in the chat, and I can give you the floor to mention it. But basically, there was a fundamental change in the ball that I don't think was really admitted for a while from the MLB, but you can see some of the evidence of that here.
Yeah, there's I served on a commission that looked at home run hitting for a number of years, and we saw some significant changes in the ball, in terms of the drag coefficients of the balls. And so really, I think 2017 and 2019, the drag coefficients were low. And that led to a great number of home runs. 2018, things dropped off, and 2021, and I think Major League Baseball has even admitted this year that the ball is a bit dead. They're doing that on purpose. So I think, honestly, Major League Baseball's got a lot of work to do, because I think the game needs to be more entertaining. I was thinking about that first talk in our conference about the change in how a basketball game ends, and that has led to more exciting basketball. Well, I think baseball might want to think about ways of doing interesting things to make the game of baseball more exciting. I think there are a lot of possibilities. That'd be a good thing to work on.
Yeah, I think that excitement is I know baseball, but that's been a question around baseball for a while with the changes here. Jim, are you okay to share your email if anyone needs to get in touch with you?
Yes, I very top of my email is should be there.
Very top of the R mark down there.
Yeah, they're Albert at bgsu.edu. Yeah, happy to. Yeah, any questions you have, I have a blog where I talk about things every week. I'll be posting something on Monday, I think. And so, yeah, so I'm happy to entertain questions. The nice thing about R is that the interface is getting easier and easier. R Studio has made a lot of improvements. And I think, it's a little easier. It's just remarkable what's available in the data. I mean, it's just, you have so much at your disposal, so you can address a lot of interesting baseball questions.
For sure, and this kind of branches around all sports. So for all students or people that are here at Ohio State, I know that Dr. Ruddy and me both teach courses in sports analytics, and teach courses in R. Happy to help with anything that you guys need with that. I'm sure Jim is willing to, if you want to reach out on some of the baseball stuff and some of the things that he's done. We don't want to inundate him. He's enjoying, you say you're enjoying your tennis life, so I want to make sure you get time to continue.
Yeah. So
But-
I just bought a new racket last week, so I have more reason to play. So yeah.
All righty, well, Jim, thank you so much for joining us. Thanks everybody for coming on. We will take a break here for lunch. We'll have a break from 12 to 12:45. And then at 12:45, we will have our workshop working on thinking about working with big data bowl data. So this is tracking data for the NFL with Asma Toomey. She'll be joining us then. Until then, have a wonderful break. Enjoy your lunch. If you are on Ohio State's campus and like to stop by, we will have some pizza and some drinks in the Mason Hall Rotunda. So hope to see you there. Thanks again, Jim.
Great. Well, thank you.